Welcome back again. In today's video, I'm going to do an analysis on the apparatus we're asked to provide on physics practicals, paper 3. Now, I'm going to look at question 2, which is optics. We're asked to provide the following apparatus. Number 1 is the plane mirror. Look at the plane mirror here. Okay. Now we have the rectangular glass block. Okay, we have the optical pins, the plain paper, and the tracing board. So with these apparatus we're asked to provide, I was able to come up with something like this. I want you to watch this video to the end so I can understand how to perform this type of experiment in case Waec repeat this question or something similar to it. Okay? To the disclaimers, I didn't say this is the Waec question, but this is what I was able to come out with. I said let me share with my community so that they can see it and learn from there in case Waec repeat these particular questions. So with no further ado, let's get right into the video. Okay, now for us to perform this experiment, I must show you the apparatus that you need to perform this experiment. The first thing I have to provide is what? The rectangular glass block. Look at it. This is rectangular glass block, okay? Now followed by the plane mirror. Look at plane mirror, okay? Plane mirror has, this is the reflecting surface, this is the back of the plane mirror, okay? Now I'm equally going to add a lens holder. What I'm going to use to hold the mirror so it can be firm on the glass block. Alright? Now we have the optical pins and the thumb pins. These are optical pins, right? These are thumb pins. Okay, so I'm going to teach you how to perform this experiment. So the only thing you need to use for this experiment are just your pencil and your eraser, the protractor, and the ruler, small ruler. Okay, that can go. Now the first thing we are going to do is to hold our paper with our thumb pin. Okay, I'll do my thumb pin. Make sure it is okay. We drag it. Okay, the first step we're going to take is to place the glass block on the drawing sheet and draw its outline as shown in the diagram. Okay, so let's just place it here. We're going to place it here. Let's draw it. Just to draw the outline. Okay, you can look at it now. Now we are done with the outline. We can use our small ruler to complete it. Although it doesn't have effect on what we are doing. So the next thing we are going to do now is to remove the glass block and record the width. You know what is width? This is the width of the glass block. This is the width. Okay, so let's measure it. So I'm going to measure it. Let me measure it. Starting from 0. I have what? I have 6.2. So let me just write it here. This is the width. Okay? And this is the width of the glass block. So the width, which is W, is equals to 6.2 centimeter. I hope that is clear. Alright. And the next step is for us to draw our normal. Draw a normal ON to DC at a point about 1/4 the length of DC. So let's label it. We say this is A, B, C, and what? D. So let's measure this line and know what we have. The next step I'm going to take is for me to measure the length DC. That is the length DC. Okay, let me measure it. Okay, let me measure it and see what I have. Okay, so the length DC is what? Is 10 centimeters, okay? And this is 10 centimeters. So what I'm going to do is I'm going to divide it by 4. So 10 divided by 4 is going to give me 2.5. Okay, so at 2.5, I'm going to make my normal. You know what is normal, okay? Just that. Get my ruler. See the ruler here, okay? Place it here. Measure 2.5. This is 2.5, okay? This is 2.5. So now look at the protractor now. This protractor, I'm going to place this point here on that 2.5, okay? Then the outline of this glass block, I'm going to place this on this other horizontal line. Do we understand? So remember that the 2.5 will be placed at what? 90, which is at this point, for us to make our number. So let's go. You can take it back, you can take it front, you can keep it here, you are still correct. You can keep it this way, you are still correct. So whichever way you choose to do your get your number, we are still correct. So placing it here, you are going to have you put dot, right, at this 90. We are trying to make our number now. So the next thing we are going to do is to join this line. Okay, and this is my line. So what's the next thing I'm going to do? The next step is to make angle of incidence I to be 10 degrees with the normal. So if the question says, you have to look at the instruction very well. If the question says from the normal this way, that means you're going to place it back and measure angle of incidence from here to here. But if the question says from this horizontal, if the question says from the surface of this glass block, you're going to measure it from here. So for this particular question, we are using this. Okay, now look at it now. How do I make my number? I'm going to make my number by saying this is from here to here is what? 10, right? You know, this is 90, which is my number. Now this is what? 80 from here, or even 100. Difference between 100 and 90 is 10. Okay, because I have to make I equals to 10 degrees. So that is all. The next thing I'm going to do is to join it by joining this point to the normal. Okay, remember that this number is 90 degrees, so you must show this icon that this is 90. This is a form of 90 degrees. Okay, all right. The next step, replace the glass block on this outline. All right, so we place our mirror. Look at the mirror here. We are going to look through the glass, through the face CD, to see where the image of this is coming out. Now we place our mirror. Make sure the mirror laps this way. Hope you can see it now. Okay, now we are going to put our P1 and P2. Do you understand? All right, so the next thing we are going to do, we are going to look through the face CD. We are going to look through the face CD to see if you can see the two pins P1 and P2 looking through the glass and also through the mirror. Okay, to see them in a straight line. That's what you're trying to do. All right, so let's go. Make sure you use one eye to avoid error due to parallax. Okay, now when you do that, you're going to see this. Okay, so I'm using P3 to cover P1 and P2. So I'm going to use this last P, which is P4, to cover P1, P2, and P3. That means all of them are in a straight line. So looking through the glass, so you have this. Okay, can you see it now? So when you look through the glass, you're going to see them in a straight line. What I'm seeing, I'm going to see just P4 because it has covered everything. Do you understand? All right, so with this, we can say that it is in a straight line. Okay. Now, it's always advisable that when you remove your pin, you do what? You circle it, okay? To avoid error due to parallax. Okay? All right, so that's all. Remove your mirror, remove your glass block. Now, because I place my mirror on this side, so it's advisable you draw something like this on the mirror. Reason is that so that the examiner will know that something was placed and it was a plain mirror. Okay, this means this is the back of the mirror, and the work of this plain mirror in this experiment is to bring the reflection outside. You don't want the reflection to be inside, okay, or this way. So you want to bring it what? This way. So the next step we're going to take is to join these 2 points. Okay, you join the point. Okay, and when we join the point, we're going to make a point here to make our second number, because we have 2 numbers. Okay, how do you make our second number? Remember what I told you. Place this point on this point. Okay, all right. So also taking your 90 degrees, which is your normal. So I'm going to place it this way to take my 90 degrees. You can place it like this, it is still okay. You are still going to be correct. And make sure that the outline is on this line. So we'll have that. This is going to be 90. Okay. Now we'll place it this way. All right. Now we'll place it this way. Okay. The next thing we are going to do is for us to measure this distance from here to here. This is what? Another normal. Let's measure the distance, okay? Let's measure it. This is D. This is 1.4, okay? This is 1.4. So if we divide it into 2, it's going to give me half of it. That is 0.7. I'll have 0.7. That is 0.7. I'll make a point on the midpoint of it. You understand what I just said? When you measure this distance between the two normals, this is n. This is n what? Prime, okay? Now, when you measure the distance between them, that is d. And I got what? 1.4. So my d is 1.4 centimeters, okay? Now, what I'm going to do is to find the midpoint. Midpoint is just like dividing it into 2, okay? You're going to have 0.7. So I made a mark on the 0.7 so I can extend that line to the what? To the outline. So let's go. Okay. And the next step is for us to join these 2 points. Join it to this point. Join it to this point. You understand? What you are going to measure from this experiment, you are going to measure D, okay? And I already have my I, which is 10, because I started with I equals 10 degrees, okay? I'm going to measure my E, which is emergent, and also my theta, which is the angle between these two normals. Is that clear? So how can you measure that? All right, we can measure my E, emergent. Look at the emergent simply by placing the normal this way. Alright, the next thing we did was to measure our emergent. Just place this on the normal. Place this line, okay? Place this on the normal. Look at it. This is the normal. So place it on the normal. Okay? When you place it on the normal, you can place it this way. Then, okay, so I have now this is 10. From 90 to 80, difference is 10, okay? So this is 11. So now let me correct what I wrote before. This is 11. This is 11 degrees, okay? From what I have, your own might differ. So depending on what you have, okay? So the next thing I'm going to measure from this experiment is to measure my theta. Look at the theta here. Okay, this theta is the angle between this that we extended from this point of normal to form here, okay? Now I'm going to measure it simply by putting this the protractor here. You can place it this way, okay, and read from this 90 to go this way. So simply by doing that, okay, by placing it this way, right, the angle I'm measuring is the angle between this line and this line, right? So you just come here. This is what we are starting from here. We are starting from 90, okay? So from 90 to 100, I have 10, I have 11, I have what? 12. So what I measured from my own is theta to be 12 degrees, okay? That does not mean that your own is going to be the same as 12, but it depends on how you trace your own, but this is how it's going to be. Do we understand? So the next step you're going to do, we have measured everything we are asked to measure, which is what? We measured this I, we started with I, and measure D, okay? This E, and this is what? Theta. So the next thing we are going to do is to evaluate. That is M. We say you should evaluate M, which is what? Sine E, okay? And we are also asked to find what? Our N. What is my N? My N is cos bracket theta divided by 2. Okay, that means Anything you have here is your theta. If you divide it by 2, it's going to be what? 6. Okay, you're going to find cos 6. Whatever thing you have is going to be your n. Do you understand? We're going to repeat this procedure the way we did this one when I equals to 10 degrees. We're going to repeat this procedure when I equals 20 degrees, 30 degrees, 40 degrees, and 50 degrees. Then after that, you're going to tabulate your readings. So let's go over to the board. Let me explain how you're going to tabulate your readings. Now you're going to repeat this experiment when I equals what? 20 degrees, 30 degrees, 40 degrees, and 50 degrees. Do you understand? So the same method, the same procedure, okay? If you follow this procedure the way I explained, you're going to realize that your theta may increase, angle of emergent is going to increase, your D is going to increase. Do you understand? So that means the trend increases. As the angle of incidence increases, the trend increases. Now, mind you, if we decide to start with what? 50, 40, 30, like that, that means it's going to do what? It's going to be decreasing. That is opposite. Do you understand? So if they choose to start from 50, maybe to change the question, start from 50, 40, 30, and to 10, okay? That means that your E and your D and your theta is going to do what? It's going to start from here to do what? To decrease, because this becomes the higher angle. When you have done that, you can get your M, which is sine E, okay? Then N is what? Sine theta over 2. So now anything you have divided by 2, you're going to find the cos of it. That becomes your N. There are some precautions you need to know about this practical. One, you must personalize it, okay? Because you are the one that performed this experiment, okay? You're going to say that I avoided error due to parallels when reading through the protractor, okay? You're going to say that I ensured neat traces. You're going to say that I ensured that the pins are vertically erect. Do you understand? So these are the precautions you're going to note. Now you should get acquainted with the short structured question that they can ask you pertaining this experiment, okay? They might ask you to state 2 conditions necessary for total internal reflection to occur. They can even bring up questions that you may be required to calculate the refractive index or to calculate the critical angle. Do you understand? So you should learn something close to that aspect. Now for question 1 and question 3, I'm still working on it until I bring out something tangible pertaining the apparatus provided. If you are joining us for the first time, don't forget to subscribe to this channel and turn on notification to get notified each time I post videos. And lastly, do not forget to share so that other students that prepare for this same forthcoming exam can see it and learn from there. I will see you next time in the next one. Bye for now.